Florida, off-bottom oyster culture, relatively new industry. I mean, really with water column leases just let a decade ago. But it's an industry that's fast growing. We have over 120 growers now in up to 12 coastal counties. The USDA Census of Aquaculture that Paul referenced, we're looking at $10.5 million in sales value. It's an industry that has many attributes and many challenges. And the challenge I want to address today in this project is that of unexplainable mortalities that are seen in spring and in summer, with reported mortalities of up to 50 to 90% in some lease areas, both triploids and diploids. And this is not just a local or state problem. This is a challenge facing growers throughout the South. So first I want to just go over, to start off, we did a preliminary study initiated in 2020 to begin to address this mortality. We looked at basic but key relationships between production, health, and environmental factors. I gave these results at the Oyster South Symposium in Ocean Springs a couple of years ago. I just want to quickly review the results from monitoring oyster and growth and survival at a couple of commercial lease areas. Alligator Harbor, a high salinity site where these mortality events typically occur. Oyster Bay, in a more open water environment and located in the adjacent county, but a medium salinity site. We look at the growth differences right off the bat. We started in October 1 with 20 millimeter shell heights oyster. 6 months, it reached 3 inches. That was our targeted size for this study. In March, took an additional 3.4 months to get to that same size in Oyster Bay in July. Let's look at the differences in growth, which were negligible, less than 2% during the first 6 months through March, then increasing by May up to 25 to 31% at the Alligator Harbor site, 8 to 13% at the same time at Oyster Bay, and then doubling by July. So these preliminary results show that there are differences in production, even using the same stocks. We used 2 different triploid stocks, even in adjoining counties, and just showing the differences in environmental conditions. And also that these mortalities tended to be associated with higher temperatures and salinities. So in 2023, my slides aren't showing up right. In 2023, we expanded the pilot study by increasing the number of farms. That would allow us to provide greater replication across the state, evaluate various growing environments. We identified a network of growers in 8 water bodies on both coasts. It's 3 components to the Oyster Farms project, and I don't know why there you go. We're providing the same stocks of oysters, which serve as sentinels at each of the farm. We're monitoring water quality at each of the farm site, and when funding is available, assessing health. So to get started in 2023, we had some clams that we had, excuse me, I'm a clam person too. We had some triploid oysters from another study that we harvested just to get started and to provide to growers in April. Again, they were large, but we wanted to just see what would observe that survival over those at-risk months. Now, since then, we've provided triploid seed, 10,000, and some half-sibling diploids in August of the past 2 years. That means those oysters are going to be reaching that market size in spring and summer of the following year. Now, growers use their own culture gear, provide their own maintenance. We just ask that they observe and report mortalities as well as harvest information so we can get some idea of survival and growth. For those water bodies where there's not water quality data available, we give each grower an in situ aquatrol that allows continuous monitoring of temperature and salinity on the farm, actually placed in a bag. And then the growers are able to download that data via a mobile app and Bluetooth. And then that is posted to a dashboard you see here and archived as monthly graphs again on the website. We had some funding in 2023, so we were able to do a health assessment on those oysters. So we provided kits to growers to ship samples to the UF College of Vet Medicine in June, late June. Now, histology is an important screening tool, and it was used to detect the presence of major pathogens and pathological conditions. Now, in histology, tissues are sectioned, stained, and then they're observed or examined under a microscope. In this study, we went ahead and took the section with the stain slides. We scanned them and annotated them and developed algorithms for 3 tissue types: the mantle, gastric or visceral mass, and gills. Then we use those algorithms to inform AI to analyze the conditions. So we did a baseline sample in February of the oysters prior to distribution to the growers. And that image you see there is the algorithm applied to the GI tract or visceral mass, in which we provided or defined colors for the different tissues, cells, and even pathogens. So now here you're seeing paired slides of the histo slide using the typical purple stain, which nobody can understand unless you are a pathologist. Then we took that same slide and applied the algorithm that you see here. Now these oysters were healthy in February. The GI tract or visceral body, you see fat cells, that's in the light tan. In the right-hand side, differentiated gonads. And the epithelium and the gills are full differentiation of cells. You've got blue color cells there. That's the mucus. There's gland cells, pink. And then on the left-hand side, you see healthy mantle, and that the fat cells, those are tan cells, are contain lipid. You see a little bit of this dark purple, blue purple color. Those are hemocytes, minimum. Hemocytes are immune cells that aid in the cellular defense of invertebrates. Now for the next set of slides, I'm going to show you some results from a couple of the farm sites in which you'll look at temperatures, salinities, and observed mortalities. So this is back to the Cedar Key site. We ran this from April to August. So in Cedar Key, average salinity of 26, temperature reaching 90 degrees in June. This is Florida. Maximum, this was a heat wave year, maximum of 94 degrees in August. In spite of that, we observed minimum mortalities, less than 5%. In fact, we actually wanted to continue raising them until they died, but Hurricane Idalia took care of that. And then we have a health report for each of the farms. Again, these samples were delivered, to the in late June. Here and for the Cedar Key site, we're seeing heavy infiltration of these immune cells. Again, the hemocytes in that dark blue, both in the gills and in the stomach. Now you're seeing a lot of this magenta color, perkensis, in the stomach, and then actually all of the visceral mass. Perkensis marinus is the pathogen that's responsible for dermal disease in oysters. What else? So in the visceral mass, you see some gray area. Well, that's the fat cells degenerating. So you got some sick oysters going on. They just don't know to die yet. All right, Indian River is our southernmost site on the farms project, is a high salinity site, average of 32 degrees over that 5-month period. Because it's further south, you see temperatures actually reaching 90 degrees in May. The grower here did report crop mortalities on the farm, market oysters, both triploids and diploids, as early as April, and then mortality of the sentinel oysters beginning in June at 30%. And by the end of July, 80% mortality of the sentinel oysters as well. All right, so here you're looking at paired images where on the left, there's a tissue from a healthy animal, and then on the right is a tissue from one of the Indian River sentinel oysters. So if you look on the upper right, you have significant atrophy of the gills. Again, those dark purple, blue purple cells, those are hemocytes. Going down to the GI tract, again, now you're seeing that magenta color. So you've got perkensis in the stomach or the rectum there. The gray is the degenerating fat cells. Now look over on the left, and that's the gastric gland cells in green, and they're starting to shrink. Again, fat cells disappearing. And grossly on the bottom, you see compaction and atrophy of the gastric gland. Pensacola Bay is the westernmost site in Florida, and it's one of the few sites where we do have lower salinities. In fact, during this period, salinities were less than 10 for about 6 weeks, but an overall average of 16. Crop mortalities, again, were noted on the farm of market oysters as well as the sentinel oysters starting in June, and then by August, overall 70%. But, you know, these oysters are large by then. And of course, they would have long been harvested. All right, real quick, health check on Pensacola Bay oysters, sentinel oysters. Again, you're looking at these paired images, healthy tissue on the left and the tissue from the sentinel oyster on the right. Again, severe atrophy on the gills. You're actually losing 50% of the soft tissue, the epithelium, in the lower right. Now, grossly, you're looking at the, excuse me, where am I at? Okay, gill atrophy. Actually, the filaments are split and they don't even extend to the mantle fringe. And then on the left, again, you're looking at a lot of hemocytes, infestation of hemocytes in the mantle tissue. Interesting, there was only moderate Perkinsus prevalence, and that's not surprising since that's a lower salinity site. So for more information about the FARMS project, there is the website there and QR code. And Bill, it is now your turn.
So I'll just wrap this up. Yeah. So that was this on? All right. This is part of a project. We had actually started talk about this when I was in Alabama, and it is amazing what Leslie has done with this in Florida. And Oyster South actually is the lead on a proposal that was funded by Saltonstall Kennedy. And it's taking that approach that Leslie has taken of putting an experiment, the same experiment on a bunch of commercial farms with environmental monitors. And what we're trying to do with that, if you saw my talk yesterday, the 3-minute tech talk, that's crowdsourcing. We're not trying to control anything. We're just asking you what's going on your farm and trying to go out and learn from those what's happening, right? But people are growing different seed, different gear, et cetera. This is taking that idea that Leslie has and now taking the same experiment and putting it on a number of farms. So that started in January and then goes through end of next year. And it is essentially many of the people in this room that were involved with that. It is a common experiment, so it's diploids and triploids. I can't say diploid and triploid, I'm sorry. I say diploid and triploid, sorry. Dips and trips. And they're half sibling. And they're going to be deployed in experiments at each site this summer. And you can see they're not evenly distributed. It really was the team decided where are the most commercial farms. And so that's why they're sort of unevenly distributed across the South. Obviously, that is changing with more farms coming up, but it's a start. I will say we have to follow state regulations about seed. For the experiment, we would love to have the same seed and deployed at all 20 farms. We can't do that. We are controlling, for example, on the East Coast, we are controlling that I think all these, everything on the East Coast is going to be produced at Oyster Seed Holdings as half siblings. The Florida stuff will be Florida, so they're not exactly the same seed, but we're trying to control as many things as we can. And I think, Scott, is Scott here? Scott, are you taking care of the, I think, providing? So we're just trying to control as much as we can by having the minimum number of hatcheries involved with that. And so just like Leslie explained, we're going to look at the environmental variables. We're going to put those oysters out probably on farms June and July of this year. And we're going to monitor air temperature, water temperature, salinity, and we think a big one could be dissolved oxygen, although we're a little worried about sensors being reliable over that time. But we think that that might be something that's going on. And over that time, we're periodically going to go out with those farmers and assess oyster health, oyster survival, and growth. And we're really trying to just get at when we control those factors, do we see any patterns? And that means I'm done. So the FARMS implications are we're really trying to find those common factors for mortalities. Is it a sums event or not? And then really trying to share information ideas and strengthen the connections within the oyster community. So we would love to do this at more farms, but the funding right now allows 20 farms. So I think if you're interested in participating, you would talk to your local extension agent. Some states may have already moved forward with their selections. So I don't know, we've sort of spaced that out to different groups, but there may be an opportunity in your state to participate.